Okay, we're going into the second portion of Lab 11. I've already removed the circuit from the board. This is doing a BJT switch. In a lot of ways, this is actually a simpler circuit to build than the first one we started with. And it's just using as a switch where we'll go from off, cut off, to full on and saturation, where we're just using the BJT to turn it either full on or full off. I have this handy picture here, which I really like. However, the one thing that's a little backwards on it is I want you to build the circuit on the right first. So you build this circuit on the right, and I want you to note before you do anything else, even though I've already used the board, I've set it to 15 volts in the last part. I will burn my LED out here if I do not get it set down to 5 volts first. So the very first thing I do before I build anything else is adjust my supply to make sure I don't overdo power. So I'll just grab a wire here, put it here, and I'll grab this. If I move my voltmeter down, you can see I'm still at 15 volts, so I just want to dial it back to 5. I'm going to live with that, 5.15. The only reason I'm down to 5 volts is just to protect my LED. 5.15 is good. 6 would have been fine. 4 would be fine. Okay. So if I want to wire this up, all I need is a 100 ohm resistor, the LED, and then a switch to turn on and off. So I'm going to take, right here I've got 100 ohm resistor. An LED, long end's positive. This should light up now as soon as I connect it to ground. In fact, before I even put the switch in, I could check it if I wanted to. And it's very easy. I just take a little wire and make sure it's all working. And I can touch it right there. See, it lights up. Alright, I'm going to take a switch. I only need a single pole, single throw to do this. I don't have one handy, so I'll just use the double pole, or single pole double throw. I'll just ignore one end. So I put it right here. Switch in one direction. Over here has connected these two, so disconnected these. Switch it there and it turns on. Okay, you can go through and check your voltages. Will be 5 volts from top to bottom. If I come in and go across the LED, this will vary depending on the color of the LED. So my numbers here won't be necessarily what you have if you have a different color LED, or even off of a different lot. So, it's not 0.7 volts forward bias like a PN junction. This is 2.360 volts forward bias to turn this LED on this bright. That means I expect to have about 2.4 over here. Oh, that's right, because I was a little higher than 5 volts. So it's 2.66 volts across my resistor. I can now find the current through the LED. I can divide that by the 100 ohm resistor and find my current. My LED should be good up to about 20 milliamps. If I get above that, it'll get super bright and then it'll burn out. And I need enough current flowing to turn it on. Okay, this is a basic switch circuit. So I've created a switched LED. Now what we're going to do is we want to emulate a remote switch using a transistor. So I put the BJT here in place of this switch. I put the collector to my LED. I put the emitter down to ground. And then I'm going to go back and hook the base up. I got to turn the base on and off. Now when I'm all done here, I'm going to end up needing to use the same physical switch. We'll talk about that when we get there. So let's come over here. So the collector connects to the transistor. My emitter goes directly to ground, looking at the schematic. So there we go. What I've done is I've built everything going along here. I go +5 through the resistor, through the LED, 5 resistor LED. Looking back at my pinout again, the collector is the right side of this flat, and generally I face everything this direction towards me, so the flat side facing here. Some people do it the other way around, but I always find it a little confusing. The emitter is the left side of the flat, and it goes to ground. Now into the base I want a 1 kilo ohm, and the other side of that's just going to go to a switch. So I'm going to take one of my 1 kilo ohms that I was using earlier. I'll run it straight into the base. And the other side of that I'll connect with the same switch, just up to +5. And put it up here. Okay, now I do realize this is a more complicated switch than we had before, but as we mentioned in class, I could take this transistor and put it off, somewhere all the way across the room and just run this long wire to it. If it's long enough wire, I probably even need a physical resistor, so I can turn it on and off. So now I have it working. You'll go to the other next page, and you're going to go through and you're going to measure the voltage across this resistor, and then you're going to calculate the current through it. That'll be the current through the LED, and that's also the current into the collector. You'll measure the current out of the emitter, and the only way to do it is come over and measure it. If I remember right, I'm missing a fuse in this, but we'll see. This will be connected correctly anyways. But I'll measure this. Okay, yeah, I'm not getting anything here. But if I had the fuse in there, I'd be getting the current. The light would light back up. I will find that this emitter current... Oops, I hooked at the wrong spots. It's not to the resistor. I gotta get down to this. Okay, there we go. I would touch on there if I can clip on it, or I might put a little wire in there, one of those ways. Anyhow, still get my ammeter, doesn't work. But this current is the emitter current. I would expect that to be a little bigger than the collector current because the base current comes in. And then again, I can come over and I can measure the current into this resistor and find what's flowing into the base. And I want to make sure and turn it on. I can also go back and reset this to measure voltage. And measure the voltage across this resistor, which should also give me current because I could just use Ohm's law. And gotta turn it on. Something somewhere is not connected right now. There we go. Alright, so you can see it's 4.3 volts across this. So there's 4.3 milliamps flowing in. This is all the way in saturation. There's no way that I'm, that beta is applying here because this is fully open. It's flowing as much current as it can. Alright, again, I want you to go through and measure all these and then think about the fact that in class we say, hey, beta is about 0, so we can do all those calculations when it's in its when it's in its normal linear operating region. However, in saturation, you're going to find that this current's pretty big, and this current plus this current, base plus collector, should equal the emitter current. And you're going to measure those and see how close it is. It ought to be relatively close. You can expect a little bit of experimental error, but it ought to be close. All right, this will help you finish the transistor labs. Now you should understand how the transistor works. We've done saturation, cutoff, and then the first part of the experiment we did the linear region where they work as a current amplifier. In the future, we'll be using them now as an actual amplifier to take in an AC signal that represents something and amplifying that signal up. But that'll be in the next lab.